Your AWD system is trying to tell you something. It's leaving clues that it's about to self-destruct. But they're not on your dashboard. They're hidden in your oil, buried in your data logs, and written in heat signatures. I've sectioned hundreds of failed AWD couplers, and the evidence always points back to one missed step. It's a pattern that ruins nearly half the units I see. Today, we're going on a forensic investigation to find the 13 hidden clues your car is giving you right now. We'll follow the trail from a harmless data point all the way to the #1 piece of evidence. The freeze-frame confession that proves your car is killing itself. And stick around, because after we uncover the crime, I'll show you the 5-minute fix that prevents it from ever happening. Number 13, the motive. You switch to a premium, top-tier fuel, and you want proof it's working. You pull up your scanner and see it. A negative long-term fuel trim. Your engine is pulling fuel. It's adapting. It feels good, right? Here's the thing. That data has absolutely nothing to do with your AWD system. Your engine's computer is chasing a perfect air-fuel ratio, but your driveline module calculates torque using completely different sensors. They don't talk about fuel. Believing this number affects your driveline is the first misstep, sending you down a diagnostic rabbit hole that costs you time while the real problem gets worse. It's a classic red herring. If you've ever chased a ghost in the data, drop a comment with the story. If this feels harmless, you're right. It is. But the next clue is a coded message that's much easier to misinterpret. Number 12. The coded message. You find a single intermittent bit error on the CAN bus, a ghost code. You clear it, and it vanishes for a week. Is this your AWD module crying for help? Trust me, it's not that simple. Here's the thing. A bit error is just digital noise. It's a symptom of 100 possible issues, from a loose ground to a failing sensor somewhere else on the network. According to NHTSA complaint logs, these generic communication codes are one of the most common dead ends for DIY diagnostics. You might spend $150 at a shop just for them to tell you they can't find a problem. Because the real fault isn't broadcasting its name. It's just making noise. Felt that diagnostic frustration? Let me know which code sent you sideways. 3 weeks later, that digital noise gets an accomplice you can actually test. Number 11. The accomplice. Your car is a little slow to crank one cold morning. You think nothing of it. But your alternator is getting tired. Its voltage is dropping under load, just for a split second. Here's the thing. Your AWD control module is a sensitive computer. When its supply voltage dips, it can cause intermittent faults or calculation errors. It's not weak processing, it's starved processing. An official OEM service bulletin, TSB 0944.1, details how low-voltage events can trigger a cascade of unrelated warning lights and module errors. A $400 alternator is a pain, but it's cheap insurance against the module damage that's coming next. Hit that like button if you've ever solved a mystery by checking the battery first. Meanwhile, in Arizona, where heat is king, our next clue starts to cook. Number 10. The weapon. You've been proactive. You sent a fluid sample from your rear differential to a lab. The report comes back with a note. Elevated iron particles. This is the first piece of physical evidence. Here's the thing. While labs are careful to say this only indicates wear, I'm telling you, it's the microscopic dust from your clutch plates, grinding themselves away. Independent testing by Blackstone Labs consistently shows iron levels in healthy units below 30 parts per million. Failing units? I've seen them over 200. That $35 test just gave you a 4-figure warning. Just got an oil report back? Drop the iron ppm you found in the comments. Before you turn the key tomorrow, think about what that metal is doing to the fluid. Number 9. The shudder. You feel it in a tight, low-speed turn, like pulling into a parking spot. A subtle vibration, a little hop from the rear end. You dismiss it as tires grabbing on pavement. Here's the thing. That's not your tires. That's your AWD clutch packs chattering. They're supposed to slip smoothly, but with contaminated fluid and incorrect pressure from old wear data, they start to grab and release violently. My shop logs show this exact symptom is the final warning owners get before the repair bill doubles. Catch it now, and an $800 fluid service and relearn might save it. Ignore it, and you're buying a new coupler. Felt that shudder pulling into a parking spot? Tap subscribe, because the heat signature coming next is what melts the seals. If you think a little shudder is just an annoyance, wait until you see the heat it's generating. Number 8. The thermal signature. After a 20-minute drive, grab an infrared temperature gun. A healthy differential housing will read about 180 Fahrenheit. But yours, it's glowing. The gun reads over 220 degrees. Here's the thing. You're witnessing the crime in real time. That heat is pure friction. The binding clutches are cooking the fluid, destroying its lubricating properties, and hardening every seal in the housing. Factory service manuals for these units list a max operating temperature that you are now exceeding every time you drive. The cost just jumped from a fluid service to a $1,500 coupler replacement, guaranteed. Grabbed a temp gun and saw a scary number? Tell me the reading you got. 3 weeks later, that heat creates a smell you will never forget. Number 7. The scent of failure. You get out of the car, and there it is. A thick, acrid smell, like burnt marshmallows mixed with gear oil. I trust it when you can smell it, and this smell is unmistakable. Here's the thing. That's the smell of thermal breakdown. The extreme heat from the binding clutches has chemically sheared the fluid molecules. It's no longer a lubricant. It's a toxic, abrasive sludge. An SAE technical paper, 2021-01-0578, details how fluid viscosity collapses. Above 230 degrees Fahrenheit, accelerating wear exponentially. That $1,500 repair is still on the table, but now you're risking the differential gears too. You know that smell. Trust me. If you've smelled it, I want to know the year and model of your car. Meanwhile, in the Rust Belt, where road salt eats everything, the binding forces are creating another point of failure. Number 6. The forced entry. On the teardown bench, the evidence is brutal. The splines on the drive shaft flange, where it mates with the coupler, are visibly scored and worn. Some are even twisted. Here's the thing. The violent grabbing of the clutches sends shock waves through the driveline. The splines are the weakest link. They weren't designed for that kind of instant, repeated shock load. Seeing this means you're not just replacing the coupler anymore. You're adding another $500 for a drive shaft yoke or flange. Heard a clunk from the driveline on a sharp turn? Record it with your phone, because that sound means the module is next to die. Before you turn the key tomorrow, understand that the car's brain is about to give up. Number 5. The warning light. Finally, the AWD malfunction, or service drivetrain light, illuminates your dashboard. You think, good, now I know what's wrong. No, you're too late. Here's the thing. That light only comes on after the control module has logged a permanent, non-recoverable fault. It has tried to adapt, it has tried to compensate, and now it has given up. A common code, like P1889, signals that the clutch pump performance is out of range. The damage is done. Now you're facing a $2,500 bill at the dealership because they're going to replace the parts and charge you. to diagnose the failure you already found. If that light is on your dash right now, hit the bell icon. You need to see the violent failure it's about to trigger. If this seems like the worst-case scenario, trust me, the system can and will fail much more violently. Number 4. The binding turn. You're pulling out of a parking spot, turning the wheel sharply, and bang! A loud clunk echoes through the chassis as the inside rear wheel drags, skipping across the pavement. Here's the thing. The clutch pack has just mechanically seized. The plates have gotten so hot and compressed so hard that they've essentially welded themselves together. Consumer Reports' complaint data is filled with stories of this exact event, often happening at low speeds. The forces involved are immense, enough to potentially damage the transfer case or even the transmission itself. Your repair bill just hit $4,000. Has your car ever skipped a wheel and banged like that? Describe the sound. It helps others know what to listen for. 3 weeks later, the component that started it all becomes the final victim. Number 3. The body. When we pull the control module off the coupler, the evidence is scorched into the circuit board. A distinct burn mark, the plastic connector melted and deformed. Here's the thing. As the clutch pump worked harder and harder, to overcome the binding, it drew more and more electrical current. The module's internal drivers overheated until they literally cooked themselves to death. NHTSA fire investigation reports have been opened for less. This is a complete catastrophic failure. You're not fixing a component anymore. You're replacing the entire $6,000 driveline assembly. Ever found a melted connector during a repair? Let me know in the comments. That's hard evidence of a system cooking itself. Meanwhile, in a quiet suburban garage, the system dies with a whimper, not a bang. Number 2. The silence. One day, you notice your car just doesn't feel right in the rain. The back end feels loose. You realize your all-wheel drive is gone. No bang, no warning light, just nothing. Here's the thing. The module, in a final act of self-preservation, has completely shut the system down. Or, it's failed so completely it can't even send a signal anymore. The dealer repair order will list the cause of death. No communication with drivetrain control module. You've been driving a front-wheel drive car for weeks, paying for fuel and insurance on a feature that's a dead weight. Think your AWD is dead? Tell me if you've noticed a change in the rain. That's the real-world test. Before you turn the key tomorrow, know that your car's black box recorded the whole thing. Number 1. The freeze frame confession. When that final fault code was stored, the module took a snapshot of every critical sensor. At the moment of death, this is the smoking gun. Here's the thing. The freeze frame data is the module's final confession. It shows clutch pressure commanded to maximum. It shows fluid temperature pegged at its limit, around 250 degrees Fahrenheit. And it shows wheel speed at 0. The module was ordered to lock the clutches while the car was standing still, an impossible command that burned it out. It's undeniable proof that the system's programming, based on bad wear data, ordered its own execution. Now you've seen the confession. Don't move. I'm about to show you the 5-minute procedure that grants a full pardon. This whole nightmare, from the ghost codes to the cooked module, starts because the system thinks its fluid is old and worn out. So, we tell it the truth. First, you have to use the right fluid. No substitutes. Get the exact OEM-specified fluid. Second, you need a bidirectional scan tool that can talk to the drivetrain control module. This is key. Once connected, navigate to the Special Functions menu for that module. You're looking for a command called Reset Wear Data, Clutch Adaptation, or Oil Life Reset. Executing this 5-minute procedure tells the module that it has fresh, effective fluid. It resets the internal counters, ensuring it applies the correct lower clutch pressure for new fluid, preventing the binding, the heat, and the entire cascade of failure. That simple relearn aligns the car's brain with its mechanical reality. It's the single most important step after any fluid or component change, and it's the one most people miss. Now that you know how software adaptation can destroy your driveline, the next critical step is understanding how your transmission's own learning process can mask a deadly internal leak. Watch our deep dive on transmission solenoids to catch that silent failure before it costs you $5,000.